So here it is a couple days later, and I've got the Tig water cooler basically finished at this point. A couple of little details. I still need to put the switch in and a pilot light. Not a big deal. But wanted to show you where we're at this point. It is functional. I've tried it out, and so far it seems to work great. So I want to do a little walk around and show what we ended up with here. So this is the water cooler closed up, and I'll take a look at the front here. So we got an air intake up here, the power supply is behind that, and this is our hookups for the lines to the torch. Runs out there. So this is the warm water return down on the bottom. This is the cold water going out to the torch. And this one is the argon up on top. And your power runs back through the warm water return down here. And the hole there, that's what I still have to finish. That's where the switch is going to go. I think what I'm going to do, I'm going to find the combination switch with the pilot light right in it. It'll make things nice and simple. So if we come around to the back here, and I'll just move this a second. So back here we have the fans, and the radiator is inside there. I don't know if we can see that. Just probably can't get enough light in there. But there's a radiator in on the other side of the wall here. And this plastic piece down here is what I printed. I've posted this up on Thingiverse. The one that's on here is actually a prototype, which that one's currently up. I'm probably going to take it down because I'm going to put up a better version that's easier to mount. There's two up there now, and I'm just putting the final touches on the final version. There was a lot I learned as I started assembling this that needed to be changed. It's functional, it's on, but to really be practical for other people needed a little refinement. Anyways, so we got our hose coming out. That's the argon hose, goes up to the welder unit, and that one there is the power lead. And let me see if we can show that up here. So here's the front of the welder. So I've got the red one on the bottom here. That's the power lead. And this is the argon going in here. And now let's take a look at the inside. So we've got our container in there, and that's just a cheap Walmart thing. I think it's called Sterilite or something like that. But dime a dozen container. So you got your pump down inside there. If I pull this out. Excuse me, I'm working alone here, so I've got to set the camera down when I do two-handed operations. So I made two holes here for the hoses to go in and out, and the power leads for the pump just slip out by there. This pump really doesn't take a lot of power, so they're lightweight wires. We've got our power supply is sitting up in the top on the inside there. Not your traditional position in a computer case, but for this application, this is what worked best. It gave me the room to get the water tank in there and have good clearance for the radiator and everything. Now it's just up in the CD bays. So on the back here, if I can get enough light on it, you can actually see it, the fins in there, but that is the radiator back there. Get a good view. got your hoses back there, and the power leads going out. And these red wires are the ones that go to the fan that powers the two fans on the back. And that's basically it. For the computer power supply, what I did is just to get it to power on, you take the green wire that's in the I think it's called the ATX plug. It's the one that goes directly to the motherboard, the big one as opposed to the little 4-prong one. And you take the green wire that comes out, and that's your switching line, and you just ground that to one of the black wires, which is always the ground line on these ATX power supplies. And that activates the power supply to turn on. And the cord, I just used the original cord that plugs in the back of it. Just made it simple. I don't have to splice any 110 wiring on there. Just plug it in and go. And what I'll do when I set the switch up on here, I'll just use this green and black. I just have these twisted right now and taped because it's temporary. I'll have these connected to the switch on the front panel, and that'll allow me to turn it on and off. And I'll take one of the power leads that come out of the power supply, and that will activate the pilot light. And that'll complete this project 100%. But right now it's functional. I've used it, and I don't know, I ran it for a little while, welding aluminum at fairly high amperage, and the water didn't even get lukewarm. It was right as cold as I put it in, so it's definitely doing the job. There's no shortcomings on that. Oh, one more thing. I wanted to show the power connections up here. So I made this piece of plastic. I milled this out on the mill. I could have 3D printed it, but I had the plastic on hand, a nice chunk of it, and it was just easier to mill it. So this holds the block that for the warm water return and the power, which is like it's a special part you get for doing these. It's usually meant for bigger machines, and it just they actually clamp it on a stud on the welder, I think. But I drilled a couple holes in the power tab at the top there where I connected my power lead. I don't know if you can see these two little Allen screws that just holds it to the plastic, and the plastic, essentially the purpose of it is to insulate it from the metal of the chassis. So there's no electrical connection between that power lead and the chassis, because the power lead has a potential to ground, and the chassis is grounded, so they cannot be connected. Also, the radiator, and I mentioned this before, is mounted on plastic for the same reason, because, well, the water conducts, at least somewhat, when it's got impurities in it. And if you ground the radiator out, you're going to get electrolysis through the water into the radiator. It will very quickly corrode out the inside of the torch and the inside of the radiator and destroy both of them. So that must be isolated as well. So if you're interested in doing one of these, hopefully this gives you a few ideas. I just want to show you the torch here a minute. Let's see if we can do a close-up on this. I showed briefly in the casing. I got the covering on here. This is one of those braided nylon covers. It works. Once it's on, it looks like it should work quite well. It's nice and lightweight and flexible, which is a definite plus for using it because it stays out of the way. Trouble is, this particular type, there's no zipper on it, and it was extremely difficult to get it on here. It literally took me about 2 hours to get the hoses fed through this thing, because there's not enough room to get it through, and the hoses start to stick to each other where they're in such tight quarters. Maybe if it was just the 12 foot, it'd be a little easier, but this is the 24 foot. And it was murder trying to get it through there. But it's done, it's on there, and we'll make good use of it. I'm going to bring this up a little to the light here to see a little better. So it's one of the ones with the Pyrex glass on here instead of the aluminum oxide or whatever it is. It's a ceramic made out of some kind of aluminum. I believe it's an oxide. And this has it's like a diffuser that's in there, so the gas doesn't just run around the outside of the collet that holds your tungsten. It's got like a series of screens inside there. The idea is that it gives basically close to a laminar flow of the gas coming out. And it gives you more range. You can get more stick out with the tungsten with this type. And they actually make bigger ones. There's one called Fupa Cup that's really big. I think it's like about that big. But that's a little over what I was willing to spend, and I don't need it that big. For what I do, this should suffice. The other nice thing is where it's clear, it really, you can see the work. I mean, it's a little bit distorted because you're looking through glass, but it's enough that you can see where you're at, where the tip is, and you actually see the arc on this. The only thing that I noted is when you use this, you do have to set your shade on your helmet like 1 or 2 shades darker, because you are actually seeing that arc. But it's much easier to keep your distance proper, and that's what part of the trouble that I was having with the aluminum is I really wasn't getting proper spacing on the arc length. It's important even with steel, but with the aluminum it's really critical to keep that arc length as short as you can but not actually dip in. So this seems to help, and I gotta admit I still need practice with it, but just my first trial run using this, and I already saw improvements from what I was doing before. So this concludes this video, and thank you for watching. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.